Welcome to Study Loop.
Okay, so problem number 5, we're given a 3D model and we're converting that to a Fischer projection, and we're going to assign R and S configuration to the chiral centers. Okay, so I can't have the model put up in the screen, so what I'm going to have to do is try to convert that model into a tetrahedral configuration, and we can use that to make our Fischer projection. Okay, so let's go ahead and so you could go ahead and just look at the model in your textbook. So that model, we have 4 carbons in it, like so. And then the first carbon has hydrogens in it. So 1 hydrogen is going into the board or into the page. 1 is going out of the page. And then we have an OH group in the same plane. Okay, and then the second carbon again has an OH group, but this time it is going out of the page, right? Or, sorry. The alcohol group is facing you, is going towards you, so it is a wedge. Okay, and then we have a hydrogen going into the board. Okay, third carbon now, we have an OH group going into the board, and then we have a hydrogen going out of the page. Okay, and finally we get to our fourth carbon. It is connected to an oxygen and a hydrogen, so we have an aldehyde right there. Okay, so now let's take this and convert it to a Fischer projection. So first of all, of course, we have 4 carbons in there, so we start with a CHO, right? And then we have the second carbon, the third carbon, and the last carbon is a CH2OH. So I numbered it from, this would be 1, 2, 3, and then 4. Okay, so here's 1, 2, 3, and 4. Alright, so looking at carbon 2, I want to go ahead and look at it from the top. So I'm not an artist, so I'm trying to imagine this is an eye and you're looking this way. Alright, I apologize for the artistry right here, but we're looking down from the top. Okay, so looking at carbon 2, if you're looking at the top, you see that both groups would be going away from you. So what we want to do is flip this. Alright, so we want to flip it, and so the Fischer projection is gonna look like this. So you have the alcohol group on the right side, and then you have the hydrogen on the left side. Okay, and then carbon 3 is already doing fine, except we didn't write the alcohol group right here. Alright, so looking from the top, that's in the right configuration. You have both the hydrogen and the alcohol group going out of the page. So OH would be on the right side, and hydrogen would be on the left side. Okay, and then CH2OH, of course, doesn't matter anymore. It is not a chiral center. Okay, so that would be our Fischer projection. Now let's go ahead and figure out the RNS configuration. So carbon 2, this would be priority 1, and then we have priority 4 right there. And then carbon, we have a carbon right here and a carbon right here. But this CHO would be your priority number 2. And this would be priority number 3. Okay. Alright, so now that we have that, our rotation goes counterclockwise. Okay. So it's supposed to be S, but since hydrogen, our priority 4 is in front, this would be your R configuration. Okay, so carbon 3. I'll try to clear it up so we get more. Okay, so we're on carbon 3 right now. Let's go ahead and assign priority. So this is priority 1, right? And then this would be your priority 2, priority 3, and of course this hydrogen is priority 4. Okay, so that gives us a counterclockwise rotation as well, which is S. But again, since our hydrogen is in front, we're converting that to an R configuration. And that's pretty much it for this problem.